Alright, what's up guys? Here we are with our second part on EFI for our Engine 101 series. Remember last time I talked to y'all, we went over the closed loop and the open loop functions of the EFI system and how they basically work. This time I'm going to go more over our air-fuel ratios. This is basically going to be our air-fuel ratio for gasoline. Different types of fuels like diesel, ethanol, methanol, stuff like that is going to run a different type of air-fuel ratio. Is going to be a little different. But this is the main ratio for gasoline here. And like we said last time, our 14.7 to 1 is, our best efficient for best combustion and best emissions. Our targeted air fuel ratio, and they call it STOICH is what they call it. Generally, our OEM O2 sensors, our oxygen sensors, are going to be a narrow band, and they can't measure very wide. They can only measure a plus or minus 1 ratio, basically. So like where I have my dotted lines on here, this is our target, and then the dotted lines is generally like the range where the narrow band will read. And that is one of the reasons why on our fuel injected cars that you don't really see a very big power increase when we change engine parts and do different mods like to the motor, because basically the engine in closed loop is going to want to stay in that range. So you're never going to ever get really over into the max power range. Even on an open loop, the OEM manufacturers only tune like, maybe to like over to a 13.5 at the most, and that's still, even with other engine mods, is not really going to give us max power. So that's one of the reasons there. But coming down here, now we'll talk about our wideband O2 sensors. They generally can measure rich is 8 point to 1 and lean is 30 to 1. So they're a very wide band. That's a very good tool to have for when you're doing engine tuning, and also just to make sure your car is not running too rich, too lean when you're getting on it on the wide open throttle. Coming up here, as we go lean, our number is going to increase, and as we go rich, the numbers are going to go lower. Come over here, slightly leaner is going to give us max fuel economy, because now we're using less gas. If we come down here, if we go too lean will cause misfires, higher cylinder temps, damage emission parts, and increased knock in the motor from the heat, pre-ignition. You can run so hot. Being over here too lean is bad, because you can be one bad tank of gas away from basically devastation, where you knock a hole in the piston, and you definitely don't want that to happen. So coming over on the other side of the spectrum here, going to our rich side, generally our max power is going to be around an air fuel ratio of a 12.5 to 1 to 13 to 1. The slightly richer ratio is going to give us better torque, and also have a better, a little bit of a cylinder cooling effect in there to kind of starve off the heat. This ratios here are generally set for like a naturally aspirated motor. So this is be a motor not running nitrous, not running turbo or a supercharger. The forced induction cars are going to run hotter with the extra air coming into being forced into the cylinders. So it's actually better to run like even around a 12.0 or even 11.5 down there, to where you have a little bit richer cylinder temperatures to get away from the heat. But now we can also get too rich, and too rich will cause misfires, increased emissions from unburnt gas coming through. That can also clog up and damage your catalytic converters and emissions equipment, foul your spark plugs out, and also cause cylinder wash, which is what cylinder wash is where we have too much fuel in the cylinder, and it can act as like the fuel acts like a solvent, and it will basically wipe the oil off of the cylinder walls, and then you're going to have increased wear, increased blow by, reduced compression, and it's going to wear out your cylinders. We don't want to go that far over to the rich either. But that's basically kind of a general overview of air-fuel target ratios. So like when we're on the dyno with the air-fuel ratio gauge hooked up and we're running wide open throttle, this is where generally our air-fuel wants to be around in this area here. And you can adjust the fuel and the ignition timing to balance that out and stay within that range. Basically your air-fuel ratio like this also works, will work for gasoline carb cars. You make jet changes on the carbs for different areas, but you can also buy an air-fuel ratio gauge and hook it up to a carbureted car, and you can tune with the air-fuel ratio gauge off that, and you can get a carbureted car set dead on also. But the only downside from the carbureted car is it cannot really adjust for varying temperature and altitude changes and weather changes on the fly like EFI can. But so there we go, guys. That's a little overview of kind of how the EFI systems work. I'll talk to y'all later.